Hi, I'm PQ, and I'm a physicist. Newton's law helps us understand the connection between the forces acting on an object and the acceleration of that object.
Newton's first law of motion states that an object at rest tends to stay at rest, and an object in motion tends to stay in motion, unless it is affected by an unbalanced force. Newton's second law of motion states that the acceleration of an object is dependent upon the net force acting on it and the object's mass. Newton's third law of motion states that for every action there is an equal and opposite reaction.
The reaction is the same force acting in the opposite direction with equal magnitude.
Newton's laws no longer apply to objects that are either extremely small, such as an electron, or objects that move very fast at speeds close to the speed of light.
For such a situation, we have to modify Newton's laws.
In the case of extremely small objects, such as electrons, quantum mechanical effects are needed to determine motion. The theory of relativity is needed to determine the motion of objects traveling close to the speed of light.
Knowing the forces that act on an object allows us to use Newton's law to predict its motion. Example: a projectile is fired into the air at a given speed. It will only have gravity acting on it during its flight. This known force will lead to the predictable arc of the projectile. That can be summarized into a simple equation.
A equals F divided by m. If an object has mass m and is acted on by a force F, you can determine its acceleration by dividing force by mass.
And Newton's law can also be used to determine the forces acting on an object if it follows a known motion.
Imagine a child sitting on a horse on a merry-go-round. That child goes around in a circle and experiences an inward acceleration pointing towards the center of the circle.
If an object is not accelerating, then Newton's law tells us that there may be forces acting on it, but those forces are balanced against each other. The net force acting on such an object is equal to 0. Friction is a force that opposes motion. Static friction exists when two bodies are at rest. Kinetic friction exists when one or two objects are moving relative to each other.
For example, a couch sitting in your living room has static friction. To move it, you have to overcome that static friction by applying an opposing force. Once you get the couch moving, kinetic friction tries to slow the couch down. So what would happen if friction didn't exist? Everything, including you and the couch, would be sliding around constantly.
Without friction, we would be completely helpless.
So what have we learned? Newton's laws accurately describe motion in everyday situations. Newton's laws do not apply to objects that are extremely small or traveling close to the speed of light.
For such a situation, we have to modify Newton's laws.
When an object is subject to known forces, those forces can be analyzed to determine acceleration. When an object follows a known motion, accelerations can be analyzed to determine the net force. Stationary objects are one example of forces in balance.
The net force is equal to 0.
Friction is a force that opposes motion and is critical to life as we know it.